Eighth grade, we're in week 16 and we are on the last lesson of the week. We've been talking about electromagnetic waves. Today, you should be able to explain microwaves. So this person is pointing a gun at a kid practicing his baseball pitch. It's not the type of gun that you would use as a weapon. It's a radar gun, and it's used to detect speed of moving objects. It has measured this pitch to be going at 51 miles per hour. Do you know how a radar gun works? Instead of shooting bullets, it shoots electromagnetic waves. Electromagnetic waves carry energy through matter or space as vibrating electric and magnetic fields. Electromagnetic waves have a wide range of wavelengths and frequencies. The complete range is called the electromagnetic spectrum. Here we see all the waves of the spectrum. The waves used by radar guns are microwaves. Find the microwave in the picture here. It's located somewhere between 10 to the 8th and 10 to the 10th. It is part of the non-ionizing radiation and is located between radio waves and infrared. A microwave is an electromagnetic wave with a relatively long wavelength and low frequency. In fact, microwaves are often classified as radio waves, but they have a higher frequency than other radio waves. With higher frequencies, they also have more energy. That's why microwaves are used for heating food in microwave ovens. Microwaves have other important uses as well, including cell phone transmissions and radar. These uses are going to be described coming up. Cell phone signals are carried through the air as microwaves. A cell phone encodes the sounds of the caller's voice in microwaves by changing the frequency of the waves. This is called frequency modulation. Do you remember what frequency modulation is from our previous lesson? That's right. It's an FM radio, an FM radio wave. The encoded microwaves are then sent from the phone through the air to a cell tower. From the cell tower, the waves travel to a switching center. From there, they go to another cell tower, and from the tower to the receiver of the person being called. The receiver changes the encoded microwaves back to sounds. So, question. Cell towers reach high above the ground. Why do you think such tall towers are used? Take a moment and pause the video. Write down your answer. Why do you think such tall towers are used? Wow, you're back already? Okay, let's go to the answer. Microwaves can be interrupted by tall buildings and other obstructions. So cell towers must be placed high above the ground to prevent the interruption of cell phone signals. Let's talk about radar for a while. Radar stands for radio, detection, and ranging. RA from radio, D from detection, and A from ranging, R, radar. In police radar, a radar gun sends out a short burst of microwaves. The microwaves reflect back from oncoming vehicles and are detected by the receiver in the radar gun. The frequency of the reflected waves is used to compute the speed of the vehicles. Radar is also used for tracking storms, detecting air traffic, and other purposes. So, how are reflected microwaves used to determine the speed of oncoming cars? The picture helps us to understand. Do you have your answer? Great. Let's find out what the reason is that they're able to detect the speed of oncoming cars. So as a car approaches the radar gun, the reflected microwaves get bunched up in front of the car. Therefore, the waves the receiver detects have a higher frequency than they would if they were being reflected from a car that was not moving. So if you look at the picture at the top, if the car was not moving, the waves coming back would be the same wavelength as the waves being emitted. But because the car is moving towards the gun, the waves coming back are actually shifted slightly and have a higher frequency. The faster the car is moving, the greater the increase in the frequency of the waves. This is an example of the Doppler effect, which can also occur with sound waves. So, in summary, electromagnetic waves vary in their wavelength, frequency, and energy. The full range of electromagnetic waves make up what we call the electromagnetic spectrum. Microwaves are electromagnetic waves with relatively long wavelengths and low frequencies. They are used for microwave ovens, cell phones, and radar. A cell phone encodes the sounds of the caller's voice in microwaves by changing the frequency of the waves. The encoded microwaves then travel through the air to a cell tower and eventually to the receiver of the person being called. The receiver decodes the microwaves and changes them back into sounds. Radar stands for radio, detection, and ranging. It is the use of reflective microwaves that determine vehicle speeds, that track storms, or that can detect air traffic. So, if you feel comfortable explaining microwaves, what they are and how they're used, feel free to jump on into those next questions that follow. If not, please pause and go back to the video again, take a few notes, and prepare yourself for those questions. Thank you for being here. Hope you had a great week, and we'll talk to you again later. Bye now.